Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Alright guys, so our next step will be looking at turning point of a curve. Turning point of what? Of a curve. This is one of the major applications of differentiation. Are you following? Now when you do a turning point, listen please. I've started. If I write, what is that first? Turning point of a curve. Turning point of a curve is a point in a curve. Is that point in a curve? Turning point of a curve is that point in a curve where the slope of that curve, changes from increasing to decreasing. Where the slope of that curve changes from increasing to what? Decreasing. And vice what? Versa. And vice versa. And vice versa. Now listen please. If you must understand the concept of turning point of a curve, you must have to understand what we call quadratic what? Curve. I'm talking, they are talking. You pay attention after you ask me questions. What did I say last? You see? If you must understand the concept of this topic, you must have to understand what we call quadratic curve or parabolic curve. Are you there? Now when we watch turning points, we have two types of turning point of a curve. A curve can turn upward or what? Downward. A curve can either be maximum or what? Or minimum. Are you following now? Now, turning point of a curve. Let me give you an illustration. You know how we call parabolic curve, Abi? A parabolic curve. This is also known as what? Quadratic, right? Quadratic what? Curve. And I hope you are aware that all quadratic curves have a general form of what? AS squared plus what? BS plus what? Plus C. Are you there? In secondary school, if you have to plot a graph, a quadratic graph, the graph can either curve open upward or curve what? Downward. Are you there? When the coefficient of a square, of this s square rather, is what? Negative. The graph will curve, the parabolic curve will be what? Will be open upward. Are you following? If I have negative sign here, let's say I have this to be I have my y to be minus what? AS squared plus what? BS plus C. This kind of graph we do what? We curve what? We curve this way. Are you following? Now, listen. At every point in this curve, we can determine the slope of this curve, Abi? It's not so. If I'm to find the slope of this curve, I have to either take my line from here, right? I'll draw a straight line, isn't it so? From here. Then get the value of what? Of y. With respect to what? To x. Even likewise there, the same thing, value of what? Y with respect to what? To x. So along the curve, along this curve, we can get our slope, Abi? Are you there? But there is a point whereby the slope of this curve becomes what? Zero. Where is that point? The turning point. The turning point is the vertex of the curve. From here, I can get my slope. I can get my slope. Any point on the curve, we can get what? Our slope. But once we come to this point, I cannot get slope again. It means that the slope of this point here is what? Horizontal. Is what? Horizontal. And the word slope is what? A slant line, Abi. So since the slope of this point is along the horizontal, that means that my slope, which is divide the what? The s is equal to what? 0. Only point is that point in the curve where the slope of that curve either move from what? Increasing to what? Decreasing. Meaning from here, the slope is moving downward, Abi. Either. Then what again? Upward. So here we have slope, but here there's no slope. So here we have our turning point. Likewise this graph here. This probe is moving upward, right? I hear somebody. Then at the starting point, what happened here? It changes what? Direction. That point where the slope changes direction, which is here, is called the turning what? Point. And at the turning point, divide the what? The x is equal to what? 0. Are you following somebody? Please write that. Note that at the turning point of every curve, note that at the turning point of every curve, change in y over change in x must be equal to 0. At the turning point of every curve, the y dx is equal to what? 0. The y dx must be equal to what? 0. Please write, note, there are two conditions. There are two conditions. There are two conditions for turning point of a curve. There are two conditions for turning point of a curve. Number one condition is called the necessary condition. It's called what? Necessary what? Condition. Please write under this. What is what? Condition. This condition states that, right? It states that at the turning point of every curve, which we already know, at the turning point of every curve, the y dx must be equal to 0. At the turning point of every curve, the y dx must be equal to what? 0. Number 2 is called the sufficient condition. Sufficient. Condition. This says that, right? This says that second derivation, which is the 2y, I will explain just right. The 2y over the s squared. Second derivation, which is what? The 2y, the what? S squared. Must be greater than 0. Must be greater than what? 0. For minimum turning point. Are you there? For minimum what? Turning point. But must be less than 0 for maximum turning point. Must be less than 0 for maximum what? Turning point. That is, the square y over the s squared must be less than what? 0. For what? Maximum what? Maximum what? Turning point. Maximum turning point. Let me explain what we mean by turning maximum and minimum in a curve. Listen. Listen, please. Look at it. If I have a function like this and this, maximum simply means the highest point that curve will ever get to. Is it under light? Yeah, under light waves, sabi? They what called amplitude, right? Amplitude. What amplitude? Maximum displacement. The highest vertical displacement a graph can ever get a curve. The maximum. Are you following now? I think in economics we call that what? Maximum profit and minimum what? Profit. The highest, the peak is called the maximum. So at the maximum we have what here? divide the x abi must be equal to what? 0. Are you following? Then at the minimum means what? The lowest point you can ever get in a curve is called what? The minimum. And in this curve, where's the minimum here? Yeah, at the vertex. Are you following? Just use the word vertex for both maximum and what? And minimum. Are you there, somebody? So when you have the word minimum, is that when the curve is being curved downward, just like this, it's called what? Somebody? Minimum. Are you there? Then when this curve is upward, it's called what? Maximum. But don't forget that at both minimum and what? Maximum point, we have what? The turning what? Point. Is it not true? At the maximum point here, there's a turning point. The point here, this graph changes what? Direction from where? This point here. That point where the graph changes direction is called what? The turning what? Point. And we have seen that along every part of this curve, we can define what? Our slope, abi? It's not so. But at this point here, your slope is what? Horizontal. That means there is no slope at the turning point. That means my dy dx is equal to what? 0. Are you following now? Likewise that of what again? The minimum. At this point here, is there slope here? Is that slope here? No. So from here, the graph changes what here? Direction here. That means both minimum and what? Maximum have their turning point where the y dx equals to what? 0. Are you following now? But the issue now is this. If you are given an equation and they say determine if this equation has its maximum or what? Minimum. How do we know it? Know that. It's by differentiating that expression given again. You know we say we have what? First derivative function, right? What again? Second and what? And third. Are you there now? Meaning that if we are given the, let's say for instance, y equals to what? 3 x raised to power 4 plus what? 6 s was square. First simply means the what? The y the x, abi? It means I will differentiate this first. And that means what? 12 what? S cube abi plus what? 12x. Second means what? The what? The 2y over what? The s what? Square abi? That will give us what? 40 what? 30 what? S squared and plus what? 12 plus 12. Now look at this. It is at this point here we can determine if the graph has its maximum or what? Minimum point. And I said that when your second derivation, which is the 2y, the s squared, is greater than 0, what do we have there? Minimum. Greater than means what? Minimum. When this value is less than 0, it means what? Maximum. What if when your d2y over the s square is neither greater than 0 or less than 0 but equal to 0? What do you have? What do we have? It's called the point of inflection. Point of what? Inflection. Point of inflection. Listen please. Please write notes. Note that point of inflection is that point in the curve. Point of inflection is that point in the curve where the curve instantly changes direction. Point of inflection is that point in the curve where the curve instantly changes what? Direction. Let me give you an illustration. Watch. Listen, please. Listen. If I have a sine graph or a wave graph, listen, please. These are wave graph. Are you following? Huh? Are you there? Here we have what? Yeah? Maximum, right? Here's what? Minimum. Here's what? Maximum. There's a point along this line where this curve changes what? Direction. That point where this curve moves from maximum to what? Minimum. It's called a point of what? Inflection. It can be along this line, right? Is it not true? Is it not? So that means that at this point we have a point of inflection. It means that our d square y over what? The S squared must be equal to what? 0. Are you there, somebody? Okay, hope you are capturing that, right? Can we now solve what we have in this book? Huh? Find x such that x plus 1 over x is minimum. Are you there? Or what? Maximum. Find x. X plus what? Is either what? Minimum, or what? Or maximum. Are you there? Okay. Don't forget, in summary, number 1, at turning point. At what? If you can write it down to help us. At turning point, what do we say happened there? Divide the s is equals to what? 0. Number 2, for minimum, turning what? Point. Abi? What happened? Can tell me? The square y over what? The s squared is what? Greater than what? 0. Abi? Don't forget. Number 3, for what again? For maximum turning what? Point. What is happening again? The square y over what? The s squared is less than what? 0. Then for point of what? Point of what? Inflection, Abi. What happened there? The square y over what? The square x is what? Equals to what? 0. Please put this summary down before we continue. Start with the s square. Put it down. Hello. We have to find x such that x plus 1 over x is either minimum or what? Maximum. Are you there? Now please pay attention to this. Let's start with this. This is one of the simplest examples. If you don't get it, you might have issue with other ones. Or now what? If it's minimum or maximum, so what we do is to equate this with what? Y. This is like saying what? This is same as y equals what? S plus what? 1 over x. Is it not so? We are giving y as this. And let's find the value of x for minimum turning point or what? Or maximum. Are you there? Now let's watch. What do we do for? You can tell me. It's to rearrange this, right? To be what? Y equals what? X plus x is power what? Minus 1. Then remember, recall that at what? At turning point. I gave us 2 conditions, Abi. What the first condition? Necessary condition, Abi. Number 2 is what? Sufficient what? Condition. Now, at that first one, it says at what? The turning point, right? The turning point. The what? The y, the x must be equal to 0. Meaning either here, right? Or here. We don't know yet. What value of x will be either minimum or maximum. But we know that at that turning point, your dy dx, there's no slope. Are you there? It's equal to 0. Okay, let's proceed. Now let's differentiate. What do you have here? The y, the x, Abi. We give us what? Here is 1, Abi. Hope you are aware. Differentiate x. What do you have? It's 1. Here will be what? Minus. If I'm to differentiate this, the rule says what? Multiply the power by what? Coefficient of x, Abi. And subtract what? 1 from the power. We are all aware, right? So let's go. What do you have here? Minus what? X. Minus 1 times x is what? Minus x. Always power what? Minus 2. Right? So here we are going to have what? This is equals to what? 0, right? So this implies what? Let's go. 1 plus what? So 1 minus x raised power what? Minus 2 equals to what? 0. Are you following? So can we rearrange this in this form? This can also be expressed as 1 minus what? 1 over what? X all squared, Abi, equals to what? 0. Can I move this 1 to the other side? Can we move it? We can subtract 1 from both sides, right? You know, our aim is to find x. Is it not so? Is it not? What is that value of x that defines that the function is what? Minimum or what? Maximum. Let's go. Now what? When you move this 1 across, or we subtract minus 1 from both sides, what we have there? Here becomes what? Minus 1 over what? S squared abi is equal to what? Minus 1. Do you agree with me? Do you agree with me? You didn't get it? From where? Do you understand how we got it? From where? Now we got this value. Okay, we understand this part now. So what happened here? We subtract minus 1 from both sides. Our aim is to find x now. So what do? We move plus 1 across. It becomes what? Minus 1. Or you subtract minus 1 from both sides. Minus 1, minus 1. That will give us what? This, Abi? That will give us what? Minus 1. You get it this now? Okay. Can minus sign cancel minus sign from here? Remaining what? 1 over what? S squared equals to what? 1. What's the next this here? We cross what? Multiply. That will give us what? S squared equals to what? 1. How do you find the value of x? We square root both sides. Then s becomes what? Plus or minus square root of 1. You know I said something before. Listen. Whenever you are finding the value of x, when s is this square, that means that x will have two possible answers. Abi? Either negative 1 or what? Positive. Are you getting it? Like for example, square root of 4 is what? Either plus or minus what? 2. Are you getting it? Please take note of this. Very important. So that means our x is what? Minus 1 or what? Plus 1. The root of 1 is what? 1. Okay, let me come this way. Yes, plus or minus. What's the root of 1? 1. Therefore, our x is equal to what? 1. Or x is equal to what? Minus 1. But this is not all. We have to find x. We have done that, right? Such that this is either minimum or what? Maximum. Okay. Now we have seen the necessary condition, Abi, that says that at the turning point of every curve, that the y/x is what? 0. Now let's look at the sufficient. Sufficient will not tell us which of the value of x is minimum or what? Maximum. Is it clear? And at the sufficient, what do? We have to differentiate again, Abi. It means I'll find what? The second derivative function. Are you following? I'm talking now. Okay, what I'm saying. Okay. So to find the sufficient condition, let's differentiate what expression again. What's that the y/x? I guess is this, Abi? This, right? Okay, which is this, right? Okay. And let me just put it back here. This is what? The y, the what? The x is equal to this, right? So that means I will differentiate this expression again to find the 2y over what? The x squared. Is it not? Are you getting it? Okay, thank you for that sincerity. We talked about two conditions to determine if a value of x is minimum or what? Maximum. The first condition means necessary condition, Abi, which is at the turning point. Your dy dx is what? The y/x is what? Is 0. Are you there now? Then when the curve now changes direction, it can either change from left, so increasing to what? Decreasing, Abi? Either maximum or what? Or minimum. Now to know if we have a maximum point or minimum point, we have to consider what we call the sufficient condition. And that condition says what? It says that the 2y over what? The x squared, Abi, is either greater than 0 or the 2y over what? The x squared is less than what? 0. If it's more than 0, we have what? Minimum. Are you getting it now? If it's less than 0, we have what here? Maximum. If it's 0, we have what? Point of what? Inflection. Now how do we determine which of this value of x is minimum or what? Maximum? Is by getting the 2y first. Hope you know what the 2y. Second derivative. Meaning when you differentiate this, differentiate it again, second time. That will give you what? The 2y the x squared. Then after getting the 2y the x squared, you put the value of your first x into that the 2y the x squared. Anything you have, if it's greater than 0, is what? Minimum. Are you getting it now? We also try for what? X equals to what? Minus 1. Do the same thing. Are you getting it? We can't have, listen please, if we have two values of x, one can either be what? Minimum or what? Maximum. Both can never be maximum at the same time. Are you getting it? Can we not try it now? See, you get the concept? Okay, what? Listen. Now, let's finding what? The second what? Derivative, Abi? Or derivative of what? of y, is it not so? Which is what? Let's go. d2y over what? Or let's recall that the y, the what? The x is what again? What do we have? The limit. What do you have? 1 minus what? S is power what? Minus 2, abi? Okay. Now let's find this now. d2y over what? The s square will be what? Differentiate 1. What do you have? 0, abi? Is it not 0? Differentiate minus s raised by minus 2. That will give us what? Minus 2 times minus 1. Minus is what? Plus, abi? Differentiate 1 is what? 0. Let's differentiate this using power rule, abi? Multiply with what? Minus 2 with what? Quotient of x, which is what? Minus 1. That will give us what? Plus, abi? Plus what? 2 what? X. Always for what? Minus 2 minus 1, abi? Which is same with what? Minus 3, is it not? So this is same as what? 2x raised by what? Minus 3. Are you getting a gist here? Or we can say that this is also same as the 2y over what? The s square equals to what? 2 divided by what? S raised by what? 3. I will now say let's put x equals to what? 1 into this expression. Huh? Is it making sense? Can we try it out? Okay. Now what? Put x equals to what? What's the first x we have? 1, abi? Okay. Therefore, we're going to have the 2y, abi? Over what? The s square equals to what? 2 over what? 1 raised by what? 3, abi? Which is what? 2, abi? This value here we have here, is it greater than 0 or less than 0? If it's greater than 0, what do we call it? Therefore, our x minimum, s what? Minimum equals to what? 1. Yes. Why is it 1, abi? Or your what now? Or is it 2 again? Listen now, pay attention. You do not pay attention. We have the value of x, abi? Which is s equals to 1 or what? Minus 1. We want to know which of them is minimum or what? Maximum. What do you do to differentiate what? The second one, the negative, abi? And that will give us what? 2 over what? S cubed. We are not testing for the value of x. Is it what we are doing here? So that means that my d2y over the s square equals to what? 2 over, this is when s is what? 1, abi? Put the value of your s as 1 here. What do you have? 2 over 1 cube is what? It's still 2. Is it not so? 2, is it less than 0 or more than 0? More than, abi? So since 2 is greater than 0, that means that therefore our s minimum, s what? Is what now? It's 1. Is it making sense? Now let's look at what now. Let's put what? Yeah, of course, minus 1. Minus 1 raised by 3 is what? Minus 1. Divide 2 by minus 1, what do you have? Minus 2. Minus 2 is less than what? 0. So we have our s maximum at what? S equals to what? Minus 1. But let's try and see, abi? Let's try and see. Let's take the whatsoever. Okay. So we put x equals to what? Minus 1, abi? Huh? Therefore we have the 2y over what? The s squared equals to what? 2 over what? What will it be? Minus 1 always part 3, abi? And that will give us what? Minus 2. If minus 2 is less than 0 or more than 0, is less than 0, abi? Hope you are aware. Your number line. Negative first, abi? Minus 2, minus 1, 0. You know so? So since this is less than what? 0. That means that our x what? Maximum is what? Somebody? Minus 1. Therefore, s minimum is 1. Y what? X max is what? Somebody? Minus 1. Please put this down. Let's go. We are giving what? Number 2, abi? Number 3 or what? We are giving, what's the question now? Y equals to what? Find the value of what? Of x. Find the value of x that will make the function. The function here is what? X, abi? In brackets. 4 minus x. A minimum. A what? A minimum. Find the value of x that will make the function a minimum. Are you there? Very simple. What do we do here? They didn't say find the point or find the minimum point. They say, well, find the what? Value of x. So don't go and overdo. Are you following? You now find your value of y after getting the value of x. Now say, therefore, minimum point is not same as what? Minimum value of x. You get this now. Value of x is not same as what? Point. So don't confuse the lecturer. So what we do, we can expand this first, then differentiate. Or we can use what product will be. You know, who can we use? Expand first. Okay. Alright. Let's expand first. Expand the expression. What we go now? Yes. Which one? The options, the answer. The possible answers you should get. Is your answer there? Is there? It's two. So let's go. Let's expand. We are going to have y equals to what? What is x times 4? 4x minus what? X squared, right? So we say at what? At the turning point. At what? The turning point. At the turning point, divide the x, Abby. Always indicate this, very important, equals to 1, 0. At the turning point, whether it's minimum or maximum, you are changing y over what? Changing s must be equal to what? 0. Are you there? Okay. And what we call this condition? The necessary what? Condition. Is it not so? Okay, let's go. That means what? Let's differentiate this. The y, the what now? The x should be equal to what? Differentiate 4x, what do you have? Is 4. Differentiate minus x squared. This is minus x squared. What do you have? Minus what? 2x. Should be equal to what? Somebody? 0. Are you there? So by the time I move minus 2x across 0, or we subtract, we add what? Plus 2x to both sides. That means, what will it be? 4 is equal to what? 2x. Are you following? Huh? Are you getting it? We just move this across the equal sign. Here becomes what? Plus 2x. Our aim is to find what? X. So we divide both sides by what? Divide both sides by 2. Both sides by what? By 2. That means 4 over what? 2 equals to what? 2x over what? 2. Can this go with this? So what do you have? Our x is equals to what? 2. Are you there? This is the value of x. But you can test by differentiating what? What do you have there? Okay, by the time we differentiate this, okay, it's not understand what we are saying. When we differentiate this, what do you have? What will be here? Minus 2 abi? Or minus 2 is what? Minus 2 is what? Maximum. Because it's less than what? 0. Do you understand what I'm saying? So you just stop there. Is it clear? You understand the concept here? When you differentiate this, when you find your sufficient condition, which is what? Minus 2. Which is the 2y the s squared. That minus 2 is less than 0. So that means that the maximum is obtained when s is what? Minus 2. Minimum is what? When s is what? 2. And that one because we have squared now. If we have, like, if I have, let's say I have x squared equals to what? 4. To now be what? X equals to what? Plus or minus what? Square root of 4b. Is it not? Is x equals to what? Plus 2 or what? Minus. Do you understand the concept? Okay, put it down. The next question. Are you ready? Yes. The next one, number what now? Number what? Number 5. Number 5. Number 5. Who's number 2 again? It's 2. Have you solved it? Someone say 1. Someone say 2. Okay. I like the way you are just doing it. Sharp. You are already solving it. That means you understand this topic very well. Can I play here? Huh? Okay. Hope you are getting the gist here. Huh? The next one, number what? Let's say number 5 for those who are not getting it. At what value of s does the function y equals to minus 3 minus 2x, y equals to minus 3 minus what? 2x plus s squared attain a minimum what? Value. A minimum what? Value. At what value of x does this function attain a minimum value? Very simple. Right? Solution to this again. So what we do here? We differentiate it, right? Is it not so? We say at the what? Always start with this necessary condition. At the turning point, we say what? Divide the what? The s is equal to what? 0. Is that not? Is that not? So let's go. What does that divide the x? Differentiate this, what do you have? 0, Abi? It's not 0. When you differentiate any constant, the answer is 0, right? Differentiate minus 2s, what do you have? Minus 2. Differentiate s to what do you have? Plus 2x. All is equal to what? 0. So we can move this minus 2 to the other side, right? It becomes what? Plus 2. Or this is the same as what? Minus 2 plus what? 2s equals to what? 0, Abi? So when you move it, you can subtract, you can add what? 2 to both sides. Isn't it? That means what? 2x is equals to what? 2. We say minus 2 again. 2x is equals to what? 2. So what we do to find x? We divide, Abi? We divide both what? Side by what? By 2. So we are going to have x equals to what? 2 over 2 equals to what? 1. Isn't it? That is it. Right? Okay. Therefore, the value of x is what? Is equal to 1. Are you there? Now listen please. This is as simple as other examples I gave. Just remember I gave what we call differentiation table. That if we have y equals to fx, and then we have our f prime, which is same as what? Y the x, Abi? F prime x. When you differentiate sine, x is what? Cos x. Differentiate cos x is what? Minus sine what? X. Differentiate tan x is what? Sec square what? X, Abi? Differentiate log x is what? 1 over x. Exponential x is what? Exponential x. Exponential kx is what? K exponential what? Kx. And so many of them. Are you following? Now look at this. Here we have sine. It means once we differentiate sine, what do we have? Cos. And I give us something. Let's see if I have y equals to, let's say sine 4s squared. To differentiate. Pay attention to this. To help you. To help you to differentiate this. To differentiate this, what do you have? Differentiate 4s squared. What do you have? 8x, Abi? Bring it out. 8x. Differentiate sine. What do you have? Cos. Then repeat what again? 4s squared. Here becomes cos 4s squared. Do you get it, this? Let me give another instance. If I have y equals to sine, let's say 2s squared plus 8x. Differentiate 2s squared plus 8x. What do you have? 4x plus 8, Abi? Differentiate sine. What do you have? Cos what? Repeat the same thing. 2s squared plus what? 8x. Do you get it, this? If we don't have this now, let's say we have sine. What do you have here? 2s minus what is this? 25, Abi? Differentiate 2s minus 25. What do you have? So it's 2, Abi? This is 2 now. This is 0, Abi? So become what? 2 cos 2s minus 25. Isn't it? Huh? No, I'll only do this now, just for this. Just for this. But if I'm not doing everything, now become 2 times 6. In bracket, you know what I'm saying? Like for example, let's say I have 4 here. Huh? If I have 4 here, what do you do? Here becomes what? What's 4s squared? 8s. 8s times 4 is what? Huh? Huh? 32, Abi? So the y, the what? The s is what? 30 what? 2x, Abi? Cos what? 4s squared. Because we have a number here. Are you getting it now? Huh? What if we have y equals to, let's say, 2x here? What would this be? 16 what? That is when we have this product in here. This is not a product. This is not another product. The reason why it's not a product because this is a number. Now to use the product to solve this. Do you get the concept? Let me say for example now. It's better as learning this now. One. Let's say we have 2 sine 4x squared. No, we say is what? This 8x, abi? 8x times 2 is what? Is 16x cos what? 4x what? Square, abi? Why? Because I have a number here. But I can also use product rule. Y equals to what? AB to solve this. This rule says what? Divide the x, abi? Equals to what? A, the B, the what? The x plus what? B, the A, the what? The x. You understand this? So, if I have y to equals to this, what's that a here? 2. So, I divide the what? The x becomes, I'll keep one constant, 2, abi? Differentiate this, what they have. You now apply that principle now, which is what? 8x cos what? 4x squared. Is it clear now? Plus, abi? Keep one constant. This, sin what? 4x squared. Differentiate 2, what they have? 0. So this is off. This is off, because 0 times anything is 0 now. So here becomes what? 2 times 8 is what? 16x cos what? 4x squared. I think that this answer and this is the same thing. Because I have a number. But if I have something like 2x here, it cannot be the same thing again. If I have 2x sin what? 4 what? S squared. By the time we keep this constant and differentiate this, I will not have 0, I will have what? 2. Do you get it? So you don't assume that all the time you will now. Now let's apply that principle here. Now we have learned, abi? Now what? I can go back to my videos, they are on YouTube to learn more. Now what? The solution to this is that we are given y equals to what? 6 sin what? 2s minus 25, all in degree. This is called degree, not 0. Do you get the concept? So we don't say the power is 0, it's called degree. Are you there? Okay, so at the turning point, at what? The turning point. Divide the x, abi, is equal to 0. Are you there? So let's differentiate this now. It means I'll differentiate this, abi, with respect to what? To x. So what do you have? Divide the what? The x. It equals to what? Differentiate this cofunction. What do you have here? So it's 2. 2 times 6 is what? 12. Abi? Yes, what? 12. Cos what? 2x minus 25. Do you get the gist? You didn't get it? Differentiate this is 2 now. 2x, differentiate the log, this is 2, because this is 0 now. This is what? 2. So 2 minus 0 is what? Is 2. So 2 times 6. You know, I can apply that principle because there is a number. Do you understand? So what do you have there? 12. 12 cos. Repeat the same thing again. Do you get the gist? All in what? Degree. Equals to what? 0. Yes. Huh? No, now. Sign. And now, when the shape cost now, when you do this now, this is 2, abi? 2 times 6 is what is 12. Then differentiate. Now take it as a single entity. Now differentiate sign. What you have is what is cost. Then repeat what you have here. This one, yes. That is just off, yes. You get it, this? Are you following? Now, our aim is to find what? X, abi? Is it not? So how do you find X? How do you find X? The first thing is to look for a means to remove this 12 from here. You know, if I have cos theta equals, let's say 0.5. How do you find theta? Theta equals to what? Cos inverse of what? 0.5. Abi? I can only find cos inverse if the quotient of this cost is what? Is 1. Is it not so? So what we do is to take off this. What's my theta here? Theta here is what? Is this. Is it making sense? So let's remove this square from here. So to divide, Abi? Divide what? Both sides. By what? By 12, Abi? That means cos 2x minus 25 over what? 12 equals to what? 0, Abi? Over what? 12. This will give us what? 0. Good. Am I clear? Yeah, what? So we're going to have 12 can go with 12, Abi? You know what? Yeah, let's go. Cos what? Cos 2x minus what? 25. Huh? All equals to what? 0. Is that? Okay, still there. You can still put degree, right? We have our degree. Huh? Now, I've shown you that to find the cos inverse, that means I have to make this as what? Subject, Abi? Therefore, here becomes what? You can always tell them recall that if cos theta equals to what? 0. Therefore, our theta is what? Cos inverse of what? 0, Abi? It can go through this process, fine. Okay, but I don't really like bringing out this. So from here, what do you have here? Therefore, we have 2x minus 25 equals cos inverse of 0. That will be what? Take from it, 90, Abi? So we have 2x minus 25 equals to what? 90. Punch. When you punch this, you have 90. Our aim is to find what? X. Don't forget. Is it not? So I'll move this across, Abi. I'll subtract 2. I will add what again? 25 to both sides. So we have 2x rather equals what? 90 plus what? 25. So 2x equals to what? Let's add. 1 what? 115. Abi? 115. Now we find x. Then x becomes what? 115 over 2. What do you say you have again? Huh? 0.5. Okay, let me quickly repeat this again. I think I didn't do the recording. It was on pause. Here we are given that y equals to x cubed minus x squared minus x plus 6. And we have to determine the value of x at the turning points. Abi? Find the value of x at the turning points. We are asked to find just the value of x, not minimum value of x or maximum value of x. Do you get the concept? So at the turning point, the y the x is what? 0. So after differentiating this, we're going to have the y the x equals 3 times 1 is what? 3x squared minus 2x minus 1. Differentiate this, we have 3x squared. This we have minus 2x. This we have what? Minus 1. Then since at the turning point, your divided x is 0, it means I will equate this to the what? 0, right? And that gives us 3x squared minus 2x minus 1 equals 0. Then we have to factorize to find the value of x at the turning point. And to factorize simply means we have to multiply the first term, which is 3x squared, right? Multiply 3x squared times the last term, which is what? Minus 1. And that gives us minus 3x squared. Then we think of two numbers that can replace minus 2x squared, such that when you multiply those two numbers, you will have minus 3x squared. If you add them or subtract, it will give us minus 2x. I repeat again. Think of two numbers that when you multiply them, it will give us the product of 3x squared and minus 1. If you add, if you add or subtract, it will give us minus 2x. And the two numbers are minus 3x and what? And x. Minus 3x times s is what? Minus 3x squared. Minus 3x plus x is minus 2x. So we have to replace minus 2s with the two numbers, right? And that gives us 3s squared minus 3s plus x minus 1 equals to 0. Then we have to factorize. Between this and this, the first and second term, 3s is common. That simply means that if this is common, we have x minus 1 plus, on this other side, 1 is common, and that gives us s minus 1 equals to what? 0. Then between this term and this term, x minus 1 is common, which is this. Multiply with what? 3x plus 1, all equals to what? 0. Therefore, our s minus 1 equals 0, or 3s plus 1 equals what? 0, which is this. And here we have s equals to 1, or s equals to minus 1 over 3. So the value of x at the turning point is when x is equals to 1, or x equals to minus 1 over 3.